Hello, it's Keith here, and this is lesson 60 of the platform-specific series of my 68000 assembly programming tutorials. We're looking at interrupts at the moment, and we're looking at the Sinclair QL. Now what we've got here is the original min-tile example, the graphical example, and we've added sound via my ChibiTracks multi-platform music player. But the real key and the real focus of today's lesson is we're looking at how to set up a VBlank interrupt. In this case, the VBlank interrupt is being used to time the music, so the music plays at consistent speed, no matter how slow the graphics are running, because they do run a bit slow sometimes. Anyway, we're using the operating system today. Usually I don't. Let's go over to the source code. Let's see how we get the operating system to give us a nice VBlank interrupt. So what we're going to look at is we're going to look at the interrupt code and the ChibiTracks code. We're not going to look at the graphics stuff. There's a min-tile example. If you search for Sinclair QL min-tile, you should see the example for that. And there's also a max-tile version coming as well, because I've got a more advanced graphics version. Anyway, getting distracted there. Let's focus on those interrupts. Now, what we're going to do is we're going to sort of create a list of interrupts with just a single interrupt in it, and we're going to use that and replace the operating system interrupt list, and so that will be polled during the VBlank interrupt. Now, what we need to do is we need to change offset 3C within the system variables. Now, actually, in basically all cases, this is effectively memory address 2803C. So we could just do this really simply here. We could load interrupt handler vector, that is our table, and we just load that into the address 2803C. That will work fine. However, in theory, we might be using a different operating system, and so according to the official manuals, that is not a thing we should be doing, so maybe we don't want to do that. Now, what we want to do is we want to run the mtinf function, which is function 0 of trap1. Now, this will return some various registers, but the one we want is A0, which will be pointing to the system vars. So it will effectively contain the value 28000 on our system, but if that had been moved with a different operating system, the correct value would be now in A0. And so now what we can do is we can use offset 3C in hexadecimal from A0 and load the address of our interrupt handler list into that. So that will basically set up the interrupt correctly. We've then got some functions to set up the music, but the final thing we want to do to actually get our interrupts firing is we need to set the correct bits of the SR register. These 3 bits here need to be cleared, so we're using an AND to clear those. That sets the interrupt level to 0 and means the interrupt will fire correctly. Now let's take a look at this vector list. Now I think this is basically a singly linked list. So basically there's 2 long entries in this list. The second entry, offset 4, is a pointer to our interrupt handler itself. The first entry is the pointer to the next entry within the list, which would take the same format as this. So if you wanted to create 2 interrupt handlers and have them as a list, you would have here a pointer to the second one, and then the second one would have the value 0 here. But in our case, and I'm not sure quite why you'd necessarily want to do that, but in our case, we've just got a single interrupt handler here, and so the 0 here is an end of list command basically. So we need to create this, and then interrupt handler here, this long here, is actually the code that does our interrupts. Now, in the case here, we're just running ChibiTracks play. It looks like the operating system is backing up all of the registers for us, so I'm not backing up or restoring any registers here. And then we just return with an RTS, because it's the operating system doing the job for us, so we don't return with RTE, we return with RTS, and that's really all we need to do. So it was a bit of a pain figuring out how to do this, but basically that's all you need to do. Is you just need to have this structure, and then you need to pass that structure to the operating system, either with this command here or with this one here. Now, if you were really playing nicely with the operating system, I believe there are some commands to install and add an extra interrupt handler and remove one, rather than sort of hard forcing one in like this. But in my tutorials, I always avoid using the operating system as much as possible. It makes things a lot easier when you're working with memory and things, because in some cases I'm actually using bits of the memory that otherwise the operating system might think it's got, and so by replacing as much of the operating system as possible, I find that is the best way of doing things on these basic systems. Of course, you're welcome to do things in a different way, but that's how I find easiest to work with these systems. So that's what we've got. Now what we're going to do now is we're just going to quickly discuss ChibiTracks, my multi-platform music player. Obviously if you're using the interrupt handler for something else, just timing of your game or something, and then you don't need to listen to the rest of this, but I am rather happy with my music player, so we're going to discuss that as well. Now ChibiTracks is a multi-platform music player, and the intention of it is it can play a single binary file on multiple systems in the same ways. Now this binary file was exported originally for the Amstrad CPC on the Z80, and that's an AY based system, but the Sinclair QL is completely different. It doesn't support multiple channels, which the Amstrad CPC did. The same binary file plays the same though, and that's what ChibiTracks was designed to do. It's not the best player. It is a player that will play in the same way on a lot of different systems, even if they have different capabilities. That's what it's designed to do. The way it does that is it has a platform-specific sound driver, which is sort of satirically named Chibi Sound Pro, parody of the Sound Blaster Pro, which is a sound card that wasn't very professional, but it was okay for the day. And then what we have is the sound music player. The ChibiTracks is the multi-platform player that is constant for all the 68,000 systems. We have a tweener and fraction 16, which are some shared modules which I might use again. They calculate the in-between notes, so I split them out just in case I come up with better but potentially not entirely compatible versions later. Anyway, that's all we need there. One final thing we need is we need some memory. We need to allocate some memory. And so we've got this pointer to user RAM at 38000, which might be used by the operating system in some cases, which is why I try and avoid using the operating system, because I can steal all its memory. And then basically we're allocating an offset here. Chibi Sound will need, it needs under 256 bytes, but I'm sort of saying officially it needs 256 bytes. That's not actually true, but it needs something like that. And so what we're doing here is we are basically defining the offset to the song in the after the Chibi Sound RAM. The Chibi Sound RAM is used by the platform driver, but the offset, the bass, and the song speed, these are used by the music player. And so we're just defining some pointers for those at the end of the Chibi Sound RAM, and those are going to be used by the song itself. Now, when we want to play a song, first of all, just a single time, we need to run Chibi Sound Pro in it. That sets up this platform's hardware as required. It depends on the system what that does, but we just run that once. Then when we want to play a song, we load the address of the song into the variable song base, which was one of those variables we just allocated some memory for, and then we run start song. That will load in the various variables from the song or restart the current song, and then we're ready to play. And all we need to do to play and update the music is run ChibiTracks play. That will read in the next byte from the song file. It will update the platform specific hardware as required, if required, and that kind of thing. So all we need to do is use this ChibiTracks play to update our music. Now if you just had a simple game that just had music on the title screen, you don't need to use interrupts at all. You can simply just have a crude pause while you're reading, saying press fire to start or something, and just keep running that in a loop. That would work fine. But obviously for gameplay, if you're playing music during your gameplay, you want to have it timed well, and that's what this interrupt example was for. Now, as I always say, go to my website, download the source code and the build scripts, and you can use the source code in anything of your own, even if it's commercial. If you somehow make an amazing Sinclair QL game using my code and you make $100 billion, good luck to you, because that's what the tutorials are here for. Hopefully they can help other people. Anyway, I hope you enjoyed what you've seen today. Thanks for watching, and goodbye.